Hello programmers, welcome to my YouTube channel Techie Projects. So in this video I will show you the vehicle classification and segmentation using machine learning. So in that project, first we have to download the Python and we have to install all those library which is required to run that project. Okay, and let's open the terminal.
The command, whatever command I will give, you just have to type as it is and hit enter. Then system will automatically install the library. Okay. And to run the project, you have to open your project folder. And in the project folder, there is a address bar. Like this is the address bar. So here you have to click to this previous location icon, and here you have to type CMD and you have to hit enter. So that CMD will get open into that particular location. Okay. And here you have to type one command which is Python. For my case, I'm typing 3.10. Okay, but in your case, you just type Python start.py. That's it. A project will up. Okay, but for my case, it's 3.10. Okay, and yeah, so there's a login page. To log in, the credential is admin. Password is 12345, and then you have to click the login button. So basically, I have created basic user interface. Okay, for a demonstration purpose. Okay, and from here you can demonstrate the prediction for vehicle dataset 1, dataset 2. So suppose I want to make the prediction of our YOLO algorithm. Okay, so what I can do, I can simply click to dataset this button, and then system. Then you have to go to the path. Like either you can directly go by folder, or else you can directly uh, go copy this path and directly you can paste it here, and then you can go inside. Okay, suppose as of now I have clicked dataset 1. Okay, so you have to go inside dataset 1 training folder. Okay, and you have to select image accordingly. Okay, suppose you are clicking dataset 2, then you have to click image for dataset 2. Okay, you can select dataset 1 images as well, but maybe some cases it will give you false result, or some cases it will give you good result. Most of the time it will give you correct result. Okay, but some cases it may not work. Okay, so then you can go to any folder like training, testing, or validation. Okay, let me go to test. Okay, and then you have to go to inside test folder, and here are the some images, so you can select any of this. So let me select this one. Okay, this is the bike image. And yeah, after selecting image, then algorithm will make the prediction in backend. Yeah, okay, so after making prediction, so this is our segmented image. Okay, which our algorithm has predicted. And then here you can, after closing this window, then you will get the final output, where you can see the class name, like what type of vehicle is it and what is the boundary box. Okay, like that. Same way, if you want to make prediction for dataset 2, then you have to go to the same folder, like dataset 2 training folder, and then you have to go to test folder, etc. Okay. Suppose this is the ambulance photo, so let me select this one. So yeah, so as you can see, this is the ambulance backside photo was there. Okay, so system has segmented this image. Okay, and then in the final output, it is like this. Okay, as similar way, uh, you can make the prediction and show the demonstration. Okay, and then if you want to close this window, then you can simply click to exit. Okay, and then after exiting, so now if you want to check the accuracy, the training code, and the algorithm architecture for such, what you can do, you can go inside the folders. Like suppose if you want to check training code for dataset 1, then you have to go to inside dataset 1 training folder. And if you want to go to for dataset 2, then you have to go to dataset 2. Okay, and then if you go inside, then you can see these three folders are images folders. Okay, and this is the training folder, where all the images and all graphs are available, so you can paste this in your thesis or black book. Okay, and there are some sample prediction images are there, so you can also put this one. Okay, and if you go back and if you check, there is one HTML file is there. Okay, so if you double click on this HTML file and if you open this file now, then you will see all the machine learning code, like all the training code for algorithm. Okay, just like this. Okay, here what I'm doing, I'm unzipping the folder, then I'm installing some libraries. Okay, so these are the two libraries, first one this one, and this is second one which you have to install. Okay, and then YOLO will automatically get configured before YOLO v7. Okay, we have to clone the repository, and then we have to install it manually, okay, for YOLO algorithm. But after V8, okay, they have provided predefined libraries, so we can directly install with the help of this library. So we have used the library directly, okay. And then after that, here is the code for training the algorithm, just like if you can see. So what I'm doing, I'm using YOLO architecture and the task detection, where I'm training the algorithm, okay, and I'm passing my basic model, like this is the YOLO model class, okay, and this is the image size, and this is the data, like where we have mentioned all the label and images, and this is the number of epochs, this is the batch size, and this is the name where output will get stored, okay, like that. This is the command inside. Then internally, your this library will check the environment variable and everything, like system configuration, and it will configure automatically everything, okay. And then it will start the training. So this is a training code, like it has we have done 50 epochs. That means we have trained our algorithm 50 times, okay. So yeah, so after training algorithm, so this is our final output. And yeah, then after that, what I did, I have imported libraries, and I have prepared some functions, like this is a segmentation function, where I have write down the segmentation code, where input image will pass, and it will crop the image after detecting the object. And this is the box label. It helps to draw the rectangle on the detected object, as well as write the label, like what exactly object name is there, or it will write accordingly. And these the boxes, plot boxes, okay. So this number of classes our dataset can detect. Dataset 1 having this number of classes, like bus, car, motorcycle, etc. And this is the confidential score, like where we are checking the boxes, like algorithm will detect some n number of boxes, okay. So out of those, we are just validating key if accuracy score is good, like around uh, 50 or 60, 40 or 50%, then it will draw the box, otherwise not, okay. Same way here, we are loading our base train model, okay, and then we are taking the image, and then we are making the prediction. So this is the same, where we are just displaying some random images, okay. And if you go down, so I have given you some information regarding YOLO algorithm, just like YOLO architecture. So basically, this is the architecture of YOLO algorithm. Like this is the completely neural network of YOLO algorithm, which YOLO is V8 is generally using. Okay, and this is the accuracy graph. Like this is the accuracy. We have achieved very good accuracy around. It is showing 100%, but we can't consider as a 100. This is the only dataset accuracy. It is not real time accuracy. Okay, so there's a difference: dataset accuracy and real time accuracy. Real time accuracy we can't calculate because that is real time data. Okay, so that's why we divide dataset into training and testing, and we do testing with testing data, and we do training with training data. So that is the training accuracy. We can consider 99% accuracy of our algorithm is, and the F1 confidential curve is also 99%, and recall factor is also around, we can consider 99. Okay, overall we can consider our algorithm is 99% accurate on testing data, okay. Whatever testing data we have decided on that, on dataset 1, okay. Why? Because see, dataset 1 has huge number of images are there, okay. So that's why algorithm was able to train very accurately, okay. But if you go to dataset 2, in that case, the dataset size was less. Like in dataset 1, there was around 2500 images was there, and in dataset 2 there was only 700 or 800 images was there, okay. That's why, in if you, the code are same, both uh, Jupyter notebook has same code, okay. Just the only difference is accuracy difference is there, okay. And if you check the dataset 2 algorithm accuracy, so that is around 98 or something, okay. And recall is 0.70%. This is 25 is around precision recall curve, okay. It is also good giving good accuracy around. If algorithm is giving more than 90% accuracy, that means that is good accuracy, okay. So we can consider ki both our both algorithm, or both data algorithm on both the data set is giving good accuracy. Why? Because see, YOLO V8 is very accurate, or very latest version of YOLO, and that is very accurate. That's why it is working very well, okay. So yeah, I'll be putting all this information in paper, and I will give you paper in some time or maybe tomorrow. Okay, I have to give this information to writer. Then he will study and then it will write content accordingly.
Thank you friends for watching my video. If you are new, then subscribe channel and share with your friend. Don't forget to like, comment and share. Thank you.